We are going to be simplifying radical expressions. These are your steps. Step 1, you're going to find the factors of the radicand. Remember, that's the number inside the radical. You are looking for the largest factor that is a perfect square. Step 2, you are going to rewrite the problem with the factors using the product property. Step 3, take the square root of the perfect square, leave the other factor under the radical. Step 4, if you have a variable under the radical, you will divide the exponent by the index. You may have to factor this term in order to divide. So steps 1 through 3, you've probably seen or done before. Step 4 might be new, and I'll show you what that looks like on the next page, and then after that I'll show you how to solve the whole problem. Okay, so right here, when you have a radical expression with a variable, all you do is divide the exponent by the index. So you're going to divide this exponent by the index. This index happens to be 2. If you don't see a number here, it's really a 2. So 10 divided by 2 is going to give you x to the 5th. So let's put that in real quick. Equals x to the 5th. Same thing here, 18 divided by 3, 8 is 6. So my answer will be x to the power of 6. One thing you do need to remember is if both the exponent and the index are even, you're going to have to put absolute value bars around it. 3 is odd, so this will not need absolute value bars. Okay, so now here I have x to the 7th, square root of x to the 7th. I cannot divide 7 by 2, so I need to factor this. I'm going to factor it to look like x to the 6 times x to the 1, because when I multiply variables, you add the exponent. 6 plus 1 gives us this 7. So now I can factor out this part, or I'm sorry, I can divide out the exponent. 6 divided by 2 is 3, so that will give me x to the power of 3. But guess what? This x is going to stay underneath the radical, just like that. So same thing here. I can't divide 20 by 3, so I need to break this up into exponents where one of them I can divide by 3. So actually, it's good that we had this right here because I know I can divide 18 by 3. So I'm going to use x to the 18th power times x to the power of 2. So I can divide this one. 18 divided by 3 is x to the 6th power. But then this x to the power of 2 is going to stay underneath the radical. Sorry guys, I don't know why my thing's not writing good right now. So x to the power of 6 square root x to the power of 2. Alright, so example 1. I'm going to split this up into 2 problems. I'm going to have the cube root of -8 times the cube root of x to the 9th, just to help me see it better. This I'm going to put in the calculator. So remember, you have to use this button right here so that you can put your little index of 3 in there. And then now I can put in my -8. Enter. And that gives me -2. So now this is -2. This 9 divided by 3 is 3, so x to the power of 3. Example 2. So same thing, I'm going to split this up into 2 problems. Step 1, I need to factor this out. I know that factors of 75 that our perfect squares is 25 and 3, because I can take the square root of 25 and get a whole number. This will stay under the radical in my answer. This one over here, remember this is an index of 2, and I can't divide this, so I'm going to factor it to look like x to the power of 14 times the square root of x to the 1. So, square root of 25 is 5. 14 divided by 2 is x to the 7th. And these two numbers will stay underneath the radical together. So square root of 3x. Example 3, square root of 25, square root of x to the 8th. Square root of 25, that's an easy one, that's just 5. 8 divided by 2 is 4, so I'm going to have x to the power of 4. But remember, if these two are both even, I have to have my absolute value. And that's it.